Here we're going to finish off the rest of 6.2, yeah?
Yep.
The polar circle.
The polar circle.
Of triangle, yeah?
Yeah.
So remember, I don't know if you've done reciprocation. It's like inversion was we did the circle thing.
Yeah.
Reciprocation. What do we do with reciprocation? We take was it still reciprocation with respect to a circle? Yeah, because we need to know the inversion, right? So if we have a point, yeah, we take the inversion of the point, yeah, and then draw the perpendicular line through the inversion point, and the line is what we get.
Oh,
the points go to lines.
Oh.
Okay, so this is called the polar of P, and then this line should go back to that point, right?
Yeah.
Well, yeah. So that's called the pole. The pole of the polar of P. Or you could have it the other way around. This could be the polar of the line, pole of the line, and this is the polar of the pole of the line. Yeah.
Yeah.
So the point is the pole, the line is the polar.
Yes.
Okay, and the polar circle, what was it? So you had like a triangle, yeah? So you have a triangle. So the point is, we constructed a triangle where the vertices, yeah. So we found the circle. What kind of circle do we have to find? Was there a circle? It's the polar circle, yeah.
Polar.
So there is a polar circle, right?
Yeah.
And what the polar circle does, so this is, you have to assume this because we did this last time. So we have a circle which takes the point and the polar of the point is the opposite side.
Oh.
Yeah?
Okay.
Remember?
Yeah.
And so the pole of the opposite side is the point, yeah? And I think what we had to do was we had to have the orthocenter, remember?
Mm-hmm.
So that was the center of the circle. What radius is it? And so, like, it had to be perpendicular, right? Remember?
Didn't the triangle have to be obtuse?
Yeah, it had to be obtuse, so that it doesn't go inside.
No, you can still draw that. You just let the orthocenter do it.
Yeah, okay. Where's the other one? So this is like A, B, C now, yeah?
Yeah.
And this is the orthocenter.
Right.
Here, yeah?
Yeah.
So you have, this is the orthocenter, right? And that makes the center of inversion, yeah? Can you see like what radius you'd have to make
like the geometric mean?
Yeah.
What HB and HA? Also distance to each side.
Yeah, so we did this. So we need to invert A, right? Oh, is that actually A?
You made it a right angle triangle. A should be
actually A should be here, right? And then
yeah, that's right. It's
yeah, so that's obtuse angle, yeah. So we said that for a triangle to have a polar circle, it had to be obtuse angle. Okay. And every obtuse angled one has this polar circle. You have the center at the orthocenter, Okay, and I think you just have to make sure the radius works. Yeah. So you're trying to map A. What's the foot of the perpendicular? It's here, right? A prime. This is C prime. This is B prime. Yeah.
So this was make it positive. So
Yeah. So HA prime has to equal.
R squared. So you find geometric mean of HA times HA prime.
Yeah.
And double that.
Yeah. And then you just have to show that they're equal, right, to the other ones,
Yeah.
which they are.
Yeah.
And we did that last time.
Yeah. Yes.
So assume.
Yes.
Someone did it once.
Yeah. If you really want to review it, just do the exercise at the end. Well, for you, you might want to read through it. Okay, anyway, so like it's also an important skill to be able to work with assumptions
Yes.
to further conclusions, right? Even if you don't know why those assumptions are true. So here we have an obtuse triangle, and there's a circle about H, yeah?
Supposed to have come in.
Oh, that's weird. C is in the wrong place. I think this is C prime, yeah? This is B prime. C prime.
Oh yeah.
Yeah?
Yeah. Because that's drawn the same way. So
Yeah. So this is like a circle, yeah?
Yes.
Okay. This is what we got. For any obtuse triangle, the circumcircle and the 9-point circle are interchanged by inversion in the polar circle.
The
Yeah?
yeah.
So can you see the polar circle is the blue circle, right?
Yeah.
The circumcircle is A, B, C, yeah? And the 9-point circle goes through the feet of the perpendiculars, yeah? So then, so this is where we got up to last time. We could understand that before, right?
H is the mid circle.
Yeah, it's not the mid-circle, one of two mid-circles.
Two mid circles.
What's the other bit?
Okay, hold on.
H
Okay, so in other words, the polar circle is one of the two mid-circles of the circumcircle and the 9-point circle. Okay? Okay, so how do we know there are two? We have to verify they intersect, yeah?
Yeah, because A dash is
Oh,
well, because they just do.
Okay, and it says these intersect because the triangle is obtuse angle.
Yeah, and B prime and C prime are outside, or A prime is inside. So they kind of have to.
So the B prime and C.
Yes.
yes. True.
Yes.
Yeah, so if it's obtuse, then B prime and C prime are outside, right?
Yeah. And then
Yeah.
Yeah.
Yeah, so that's why it was so hard for us to understand it the first time, right? Because they're just verifying that they intersect.
Yeah.
And we don't know why, like, the two mid-circle, we didn't know what a mid-circle was, and why there'd be two of them, yeah? But now it's clear that there's one of them, right? And there's two if they intersect,
Yeah.
and then it's clear that they intersect.
Yes.
Sometimes when people say it's clear something happens, it's actually helpful, because it's like, it should be clear, you know? It's like, we could go through an hour of explaining it, but
That's probably the wrong.
that's the wrong thing to do, you know? It's like, why? It's like, we think it should be clear, but we're making it not clear for you. Like, we'll explain why it might not be clear.
Unclear.
We're unclearly explaining it.
Did we find the other one?
Big circle.
What was the other one? Do you remember what it was? There's the other angle bisect. Do you remember?
Yeah.
I mean, we might not have a name for it. Like, if we have the two circles drawn,
So,
we'd invert about one of the point of intersection.
yeah.
So yeah, where they intersect, it's a circle through where they intersect.
Wait, what chapter is this?
6.
This is 6.2. There's no rhyme or reason to how we progress. They went 2.3, 5.7, 6.2.
It would be done next week.
Yeah. It's like corona rates.
Yes.
Okay, so it follows that the circumcircle, 9-point circle, and polar circle, whose centers all lie on the Euler line.
Oh.
So, Euler line, yeah. So if you say it to yourself long enough, it seems right. When you talk to other people, it's like, oh, we differ. Euler lines. Yeah. You know, it's funny because when I used to think, when I first heard someone say Euler, I thought the same thing about them. I was like, oh, they must just say it in their heads a lot. And they came up with that. And then I was like, oh, everyone says Euler. It's just me. It's me. No, it's me. Okay, so
Circumcenter, 9 points and 10.
So
That's a lot of
circumcircle,
circle,
9-point circle,
C and
polar circle.
So the centers of the always.
Well, we know that the ortho centers and they lie on the
Yeah.
ortho line, right? So it's basically
Yeah, that's just the peak.
that is the yeah.
This is just a final proof of Euler line.
Coaxial.
No?
No.
Wait, what?
Oh, yeah, because they are.
They have the same radical axis.
Yeah,
Wow.
because it spins.
Because we learned that, right?
Because
Oh yeah.
because it's clear.
It's clear.
It's clear.
HAHD.
Nice.
Like they only have two mid circles, so one of them, then they're both on the
Yeah, but like
on the radical axis, yeah.
Yeah.
They both have to intersect at the points of intersection, or well,
Oh, yeah.
they're intersecting. Yeah, they're the intersecting
Yes.
coaxial ones. So it's
Yeah.
where the circumcircle intersects. You know, like
Yeah.
CBA. So like
Oh,
No,
the other one is radical axis.
yeah. Oh, maybe I can draw it.
Oh no.
Oh my
Ah
god.
yeah. Oh no.
Ah.
If it's the other
It's like
one.
a really fat point.
Yeah. Very large.
Yeah, and I'm making stuff tangent that probably shouldn't be tangent.
Yeah.
And just pile it on. Just pile it on. I can take it.
Yes. Oh. Okay.
What
That totally goes through C.
What? Oh, it's meant to go through C?
Yeah, see if right.
Oh yes, you're right. Yeah.
Close
That's
enough.
hilarious. C, yeah.
Oh, it's meant to go through C prime.
Oh no.
It's like, yeah. The question is, did drawing that help at all? Alright. And that for any obtuse angle triangle, the 9-point circle passes through not only 9, but 11 notable points. This is they're just playing with us now. The last two
Why?
being the points of intersection of the circumcircle and the polar circle.
Yeah. Oh
It's
yeah.
like a
Forgot. Yes.
Oh yeah, so that's notable because it's the radical axis
Yeah.
points.
Note.
Notable.
Oh, their diagram looks so weird. Oh, they have like parabolas and stuff.
Yeah, it's funny how like
Oh,
that
man,
was
that's
that was
so
kind of a bit of a headache at the time, right?
Yeah, no.
And now it's
Yeah.
trivial.
Yeah.
It's not even like
It's not even hard.
it's not even easy.
Yeah, it's true.
It's trivial. Oh, okay. I guess it's easy. Okay, so I guess this is kind of how maths progresses sometimes. It's like people make some groundwork, some sort of fundamental lemmas and theorems, and then
Yeah.
They all
suddenly you're standing on the shoulder of a giant.
and there's nothing else to prove.
Yeah. Okay, so the last two being the intersection of the. Oh, that's it. That's 6.2. That's the end.
Hey,
Oh my gosh.
so polar triangles are complete.
Yeah.
Alright.
What's 6.3?
6.3 is conics.
Conics. Oh,
Let me just stop
yes.
that for a sec.
Oh,
Wait,
this
let me
is
just
awesome.
ask if they have any questions, because yeah.
They want
Eccentrics.
Oh, okay, yeah, they were complaining about this diagram and then I fixed it.
Ah,
Isn't A the middle point? Wait, how is the author center?
Oh, no.
There were too many complaints to write like sentences for.
Oh.
Wait, how's that the author? Oh, okay, wait, no, that's a sentence. Isn't A the middle point?
Oh,
What's happening?
What's happening? What?
I think he mixed B and C around. Yeah, he fixed it.
We
Yeah.
did it. We survived.
Smart kids.
alright.
Oh, right in time, right on time too.
Yeah, 5 minutes.
That's crazy.
Huh? Oh, is it so?
Okay, you guys have any questions?
No.
Not really.
I'm gonna stop that there.
Wait, what happens next week? Do I just come